Lesson 8.5, Perfect Square Trinomials. In the last module, we multiplied special case binomial expressions, and these were expressions that you could have multiplied using FOIL or a table, but we memorized a pattern so that we didn't have to do that work. And in this lesson, we're going to factor one of these back to the original binomials that it was originally made from. So if you recall, when we squared a binomial, it followed a very specific pattern. A plus b squared always gave us a squared plus 2 times a times b plus b squared. And a minus b squared always gave us a squared minus 2 times a times b plus b squared. And these were known as perfect square trinomials. When we multiplied or squared the binomial, we created the perfect square trinomial. Using the pattern helped us to do that, and we didn't have to do as much work. The process of factoring a perfect square trinomial is to recognize the pattern when we see it so that we can factor without doing as much work. So if we see a squared plus 2 times a times b plus b squared, it's going to be a plus b squared. And if we see a minus 2ab plus b squared, it's going to be a minus b squared. So this is what you do. Step 1 is check. Actually, that's not a good step. The first step is always going to be to look for a GCF. And then the next step we're going to do is we're going to check to see if the first and last are perfect squares. Okay, here I have x squared, that's a perfect square, and 25 is a perfect square. So the third step is to square root each. Okay, the square root of x squared is x. The square root of 25 is 5. Check to see if 2 times the square roots equals the middle term. 2 times x times 5 is equal to 10x. That matches. So then we take the square root of the first plus or minus the square root of the second squared, and it's factored. So the square root of the first was x. This sign here tells us we need to be minus. The square root of the second is 5. And so we get x minus 5 squared. So let's try a few more. Okay, I don't have any common terms I can factor out, but 16b squared is a perfect square, the square root of which is 4b. 25 is a perfect square, the square root of which is 5. 5 times 4b times 2 gives me 40b, which matches. So this factors to 4b minus 5 squared. 4x and 1 are both perfect squares. The square root of 4 is 2. The square root of x squared is x. The square root of 1 is 1. 1 times 2 times 2 is 4. So this will factor to 2x minus 1 squared. Now here, I usually like to rearrange things and put them in the order to where the squared term is in front. I have a GCF of 3. 3 will divide evenly into all of those. When I factored the 3 out, I'm left with b squared plus 2b plus 1. b squared is a perfect square. 1 is a perfect square. So this will give me b plus 1 squared. 1 times b times 2 gave me 2b. Here, I have 200m to the fourth plus 80m to the third plus 8m squared. So I'm going to check to see if there is a GCF. I know that 80 and 8 will both divide by 8, but I'm not 100% certain on 200 yet, so I'm going to check that. Okay, and 200 divided by 8 is 25. Now, I have 4, 3, and 2 m's, so I can take out an 8 and 2 m's, and I'm left with 25m squared plus 10m plus 1. The square root of 25m squared is 5m. The square root of 1 is 1. 5 times 2m, or sorry, 5m times 2 times 1 gives me 10. So this will factor to 5m plus 1 squared, and the 8m that we factored out stays the same. Now I would like you to try these three. If they're not perfect squares, see if you can factor out a GCF, and then after that, check to see if they're perfect squares, and then factor them following the pattern. Go ahead and pause the video and take some time to do that, and then come back and check your work. Okay, looking at our answers, the first one, I had a perfect square and a perfect square, so it factored to 10x plus 9 squared because 2 times 10 times 9 gave me 180x. And the second, I did not have perfect squares, so I pulled out a 10, which left me with perfect squares, which factored to 9 and 5, n and 5, so 2 times n times 5 was 10n, which matched. So I got 10 times n plus 5 squared. And then in my last example, the square root was 7n and 4. 2 times 7n times 4 gave me 56n, so I factored to 7n minus 4 squared.